After you have logged in and started your session, you should come in and find the chamber under vacuum. The door should not open and the screen should read VAC OK. The first step is to vent the chamber. To do this, first turn the nitrogen on, then push the vent button on the computer. You should hear the chamber pumping down and have to wait a minute for this to complete. Once the chamber is vented, the door should slide open very easily. Be sure not to pull too hard, otherwise the door may not close again. Always remember to put a fresh pair of gloves on before handling anything in the chamber. Take your sample out of its holder and place it in the multi-sample stage. There are 7 numbered slots, so make sure to remember which number you place your sample in. The sample touch alarm should appear on the screen. Push OK. Next, you want to home the stage. So on the computer, click Stage and then click Home. A little box that says Active will appear on the screen while the stage is homing. This may take a little while. It is very important to make sure only to home the stage while the chamber is open so that the sample does not hit any of the detectors or the walls inside the chamber. At this point, take the elephant located in front of the computer monitor and make sure your tallest sample is shorter than the 10 mm mark. Now you can close the door, turn the nitrogen off, and press pump. Be sure to hold onto the door until the pump starts and pulls the door closed. Otherwise, back pressure might cause the door to slide back open. While the system is pumping down, you want to watch the pressure gauge in the top right corner of the screen. It will not read anything for the first few minutes, but once it drops to around 10 to the -4th millibar, a number will appear. At this point, you can turn the high tension on, but wait to turn the beam on until the number reads 9 × 10 to the -5th millibar. Now that it is okay to turn the beam on, click the 10 kV button. A window will appear on the screen. Be sure not to click OK yet. Drag it out of the way and we will revisit it later. This is an important step because clicking OK links the Z with the working distance. We need to raise the top of the sample to 10 mm, but the software does not know where the top of the sample is, so in order to do this successfully, we have to link the Z with the working distance. But first, we are going to get an SEM image. So click Detectors, and then change your detector to the Secondary Electron Detector, SE. Now we have a secondary electron image. We don't know exactly what we are looking at, so in order to better judge this, reduce the magnification to the least possible value. This image is really dark, so we can use the Auto Contrast Brightness button, ACB, to adjust the contrast and the brightness. This could also be done using the panels next to the computer. Now we have a better idea of what we are looking at. It is one of the slots on the stage. Now we want to get to the edge of the stage because it is a good point of reference. From there, we can rotate the stage to find our sample. We do this by using the magic numbers attached to the computer monitor. Enter the numbers into the X and Y in the bottom right-hand portion of the screen. Now we are at the edge of the stage, so we can use the rotation knob on the microscope to rotate and find the sample. You will be able to see numbers on the stage. Rotate until you find the number of the slot where you placed your sample. Now that we have found our sample, we want to find a feature that we are interested in, which will normally be the tallest feature. There are a bunch of ways to navigate using the software. Right now, the pointer is selected, which really doesn't do much more than point. The Get mode will center on anything you double-click on, and the most popular way to navigate is with the Track mode, which all you do is click and drag the mouse, and the screen will follow. The image is still rather dark, and the ACB did not work very well. A good way to adjust the brightness and the contrast is to use the video scope. The first thing you want to do is zero the contrast out with the panel next to the computer, and then increase the brightness, zero the contrast out again, and then increase the brightness so that it matches the baseline. Then increase the contrast back to a point where it is still between the two lines. Finally, click the video scope button again to get rid of the lines. Now we are at a feature that we are interested in. Remember to go to your tallest sample and find your tallest feature when you are doing this step. Increase the magnification and start focusing. There are different ways to focus. You can use the coarse and fine focus knobs on the panel, or you can hover your cursor right outside the circles, right-click, and drag. We are trying to find a good focus in order to link the Z with the working distance. You have to remember to have your magnification at a value of at least 2000x. You can go higher, but the minimum is 2000x. At this point, don't worry about the fine focus or the stagnation, we just want a good focus of the sample. Now we can bring the small window back up. Let's read what this says. For safety reasons, it is necessary to confirm that the specimen is in focus. That's what we just did. Focus the image and confirm with OK. Z will be linked with WD, working distance. Let's take a look at our Z. It is red and next to it says NC, not calibrated. Once you press OK, the Z will not be red anymore. It will be linked with the working distance, and it will be calibrated. Now that the working distance is linked to our Z, we want to go back to the CCD camera. So click Detectors, and then click CCD. Now we want to raise our sample. 10 millimeters is the eccentric point, so that's where we want to be for the best imaging. But we don't want to jump from 22 to 10, so we'll do it in a couple of steps. First, we will go from 22 to 15, then go back to the secondary electron image, get it back in focus by turning the focus knob on the panel, and click the Z forward button in the bottom right hand part of the screen to relink the Z with the working distance. Now we will go back to the CCD camera and make the Z 10. Note how close the sample is to the other parts of the microscope. That is why we take all these steps, to make sure we are not overshooting the 10 mm mark and damaging the microscope. Go back to the secondary electron image and get it back in focus. We have now covered the basics of finding an image, so we're going to take a look at the different functions of the microscope so that we can capture the best possible image. First, we will start with the magnification. There are multiple ways to change this. The first is to use the knob on the panel. The second is to click the drop-down menu in the top left portion of the screen and choose from the preset magnifications. And the last is to hover over the inner circle and click when either a plus or a minus sign appears. The next function is beam. Here you can choose from different accelerating voltages and spot sizes. For the accelerating voltage, it is good to start at 10 or 15 kilovolts. Notice that when you change the accelerating voltage, you will have to refocus the image. There is no standard accelerating voltage. There are only recommended values based entirely on your sample. For instance, if your sample is charging, you want to decrease the accelerating voltage. As for spot size, 3 or 4 is a good place to start. You can use different spot sizes for different functions. For instance, 4 and 5 can be used for X-ray analysis, or you could use 1 or 2 if your sample is charging. The next function is scan. Here you can choose from different scan speeds. You can choose a slower scan speed for a clearer image. Now this probably raises the question, why not always use a slower scan speed if the image is better? If we try to change the magnification on a slower scan speed, you can see that the response time is really slow. This delay in response time makes all the other functions, like focusing, way more complicated. So for live imaging, we use the TV mode. When we go to higher mag imaging, this can cause a problem. The quality is so grainy that we can't really focus. For this issue, we can choose Select Area. This scans a small area at a slow scan speed, so the response time is still relatively fast. Just be aware that the rest of the screen will not be refreshing. Now we are going to talk about stagnation. Astigmatism is the elongation of your image, which suggests that your stagnation is off. This distortion really makes a difference in higher mag imaging. In order to know if your stagnation is off, over and under focus the image. The image should move, but not elongate. If it elongates, the stagnation needs to be adjusted. This is what it should look like when you over and under focus it. And this is what it shouldn't look like. Before you can adjust the stagnation, there are some rules you must follow. First, do not adjust the stagnation if your magnification is below 35,000x. It is very important to be at a high mag when adjusting stagnation. Second, you need a feature that you can actually adjust stagnation on, which means you need either a circular or spherical object, or a sharp corner. If you don't have these features in your sample, ask for a standard sample to adjust the stagnation. You cannot adjust the stagnation on something like fibers or an elliptical object because you won't be able to see the elongation. And the last rule is to make sure the focus of your image is as good as you can get it. Once you've done these three things, you can adjust the stagnation by using the Stig X and Stig Y knobs. You can choose to start with either one, just make sure you remember which one you start with. Adjust it until you get the sharpest image you possibly can, and then switch to the other knob and do the same thing. Once you are confident that you have the sharpest image you can get, focus the image and repeat the process if necessary. If you are having trouble focusing, you can use the Select Area function that we talked about earlier. Now that we have a clear image, we want to talk about saving this image. The microscope control window does not actually save the images, it only acquires them. So the acquired images need to be transferred to XL Pro so they can be stored. To toggle between the two databases, click the light bulb. Sometimes this may not be here, so to bring it up, open XL Pro, click Special, click the Edit button bars, and then click Always on Top. To save an image, click the camera icon, or push F2 on the keyboard. You will probably notice that the image being saved is of much higher quality than the live image. This is because we are averaging a bunch of times in order to get our saved image. Averaging intensifies the signal, so it is much less noisy and very clear. If you want to save an image at a certain mag, double that mag when you make your adjustments. Then drop down to the desired mag when you save the image. If you do your adjustments at the mag that you want to save your image at, there are a lot of things you will probably miss, which will only be obvious after you save the image. So now we have acquired an image. In order to save it, click on the filing cabinet icon. This transfers the image to the XL Pro database. Name it, and then click Insert. Then go to XL Pro to make sure it is there. Now the image is on the microscope's computer, but there are no drives for a memory stick. So to get the image out of the computer, you have to either burn a CD or transfer it to a shared folder so it can be accessed by another computer. You can export it to either a JPEG or a TIFF. It is recommended that you export it as a TIFF. So, if you click TIFF, it brings up the destination path of the previous user. Always remember to change this, otherwise you will be saving all of your data into somebody else's folder. You can change it by clicking on the button with 3 dots. Create a new folder if you do not already have one, and click OK. Now all of your images will be saved into this folder. When you go back to the live image, you should notice that the image is frozen. To fix this, click the Freeze Image icon. Another button to take note of is the blank beam button. If it is turned on, it blanks the beam out. It is useful to dissipate a charging sample, and sometimes certain functions of the software blank the beam out on their own. Students often forget to make sure this is off and are confused when their screen is blank. The next function to be aware of is the data bar mode. You always want the data bar on the bottom of your image. It contains valuable information about the accelerating voltage, spot size, magnification, which detector you are using, the working distance, and the scale bar. Without a scale bar, your image is meaningless. So if another user has turned it off or changed it to a different setting, always remember to turn it back on. Another useful tool is the measurement function. If you click on it, you have different options. Keep in mind that when you save an image, the measurements are not saved. The next set of buttons are some autocorrectors. We saw the ACB earlier. The second is an autofocus, and the third is an autostigmator. The ACB works alright, but the last two don't work very well, so it is recommended that you do not use them. Now we are going to use a second sample to show a few more functions. Here we have an old grid. If you maximize the stage window, you can see the other functions we are going to use. The first is scan rotation. This changes the way the beam is moving, so you can align certain features with different axes. Below the scan rotation is another feature called stage programming. With this, you can program various areas of the stage. This is useful for comparing different samples. So if we decided this was an area of interest, we would want to mark the spot. So first, clear the previous marks, and then add the spot on the stage. Now if we go back to the other sample, we can return to this one at any time. To X out of this window, push the minimize button. Now we will find a spot where we can demonstrate what charging looks like. This is some organic matter where you can see a very typical phenomenon called charging. What is happening is electrons are building up and are not able to dissipate because they have nowhere to go. So this is causing the sample to be bright regardless of the contrast. If the charging is really bad, you might not be able to save your image without seeing streaks. When you are done with your sample, turn the nitrogen on and vent the chamber. This will automatically turn the beam off. Now turn the high tension off. Change the detector to the CCD camera for the next user and put on a fresh pair of gloves. When the chamber vents, open it and take out your sample. You do not have to home the stage again. That is the responsibility of the next user. All you have to do is close the chamber, turn the nitrogen back off, and pump down the chamber. The chamber should always be left under vacuum. The door should never remain open in order to prevent contamination and polar molecules from sticking to the walls. At this point, you just have to log out and you are good to go.